Hello, my name is Shalina, and I'll be explaining how to conduct the advanced dynamic analysis on the LuckyCat malware. So the LuckyCat malware, as we know from performing the basic static analysis, that this malware file is a data link library file or a DLL file. As such, in order to run this DLL file within the debugger, it will require the uh, run dll32.exe. So before we start, right, the debugger that we'll be using is the x32dbg. So the x32dbg is the 32-bit version, is made for 32-bit malwares, whereas the x64dbg is made for the 64-bit malwares. So firstly, in order to run this file, we will be opening up the run dll32.exe file. So this run dll32.exe file is can be found within the C drive, Windows, syswall64, and you will be able to find the run dll32.exe file. So this syswall64 is the Windows system for the 32-bit executable files. So after which it will be open. And once we have opened it, we're gonna set our options. So under options and preferences, we are gonna select for the for it to break on the DLL entry. So this will be important as we will be able to identify when the DLL has been loaded and has entered. So another thing that we'll be doing will be to change the command line. So we're gonna add a space, and we're gonna add the file path of this of the malware.dll file. So I'm gonna place it in quotations. And after which we're gonna enter the export function of this malware.dll, which is get object count. So after which we're gonna save it, and we are gonna restart this debugger. So once we have restarted this debugger, we'll see that we'll have loaded into the module ntdll.dll. So we are just gonna continue running it until we run into the malware.dll file. So once we have noticed that the module name has reached the malware.dll file, we are going to go towards the symbols panel, and we're gonna look for the module of malware.dll. After which we'll notice that our exports and imports are all here. As such, we're gonna click onto the address of the export function get object count, and we are gonna set a breakpoint there. So we're gonna do the same, setting the breakpoints for the registry operations, such as the setting of registry values. We are gonna do the registry create key, registry open key, as well as the registry querying of the values. So other than breakpointing the registry operations, we're also gonna breakpoint the send function. So after we have breakpoint these few functions, we're gonna continue to run our we're gonna continue to run this malware. And you can see that we have hit the get object count. So before we actually start to debug this get object count, we're gonna set up our network operation tool. So we'll be using Apate DNS. And we will also be using the command prompt to run the netcat command. So the netcat command will be set up to listen to port 110, as we know that there is some operations made to connect towards port 110. And for the Apate DNS, we're gonna set the loopback address of 127.0.0.1 as the loopback address to listen to all the DNS being made up of the system. So once we have set that up, we will continue to execute the malware, and we will see that it will start off the registry operations. So we actually notice that from the operations before, which is to open a registry key, we notice that there is a path that is actually stated, and that we have in within this pane of all the registry information, we also see that there was an error. As such, right, we will be using the regedit tool, the registry editor tool, and we are going to add this path so that the malware will be able to detect it. So we will just add a new key with the key of resources, and we'll leave the value as defaulted. So once we have created this key, we will just rerun this debugger again. So back to the point of where we see where we breakpoint to this registry open key. If we were to actually run it, it shows that the status was successful. So so we'll just continue running this. And we will see that registry value of this value seems to be set. So we're just gonna copy down this value, and we're gonna put it into a notepad. So after getting this value, we're just gonna continue debugging. So it's seen that the registry value is actually being queried. And after which we have reached the send function. So to get the value of what is being sent, I will just follow the EDI registry. And we can actually see that a bunch of gibberish was printed out. So I'm just gonna copy all this gibberish out. And I'm gonna paste it into CyberChef. So I'm just gonna extract the text. And I'm gonna push this information that I found. So after which we'll take a look at what happens. So we will just perform a step. So we'll just perform step overs until we hit a return function to try to find any encryption keys that was being used to encrypt this information being sent. Okay, so this seems to be the point of when the function was ran before it actually called the send. So we're just gonna breakpoint this area and we're just gonna scroll up and read some of the assembly code. So we can actually see that the XOR operation is being performed quite frequently. And it shows that one of the functions actually shows that the XOR function with a specific address was actually XOR with the value of F5. So let us return back to where the value that we found here. And since we know it's an XOR operation that was performed, so we're gonna key in the key of F5. So when we actually decrypt it, we are able to see that this value here is similar to the value that we previously found. So it is actually the same value. And if we were to look at the information being sent over, it seems that it's sending over this work group and the desktop. So this is likely the settings of the current user that I'm using. So we actually go to system and info. We should be able to find out that the desktop name, the device name is matching, and also the work group of this user, which is work group. So knowing this information, we still have this string that we have yet to find out. Knowing that they were trying to perform a registry operation, so we're just gonna take a look at the this web resources where they were trying to access, and we're gonna refresh this key. And we are actually able to see that a new string has been created. And if you were to click onto this string and view the binary data, we will actually notice that this string is the same as the one written in this that we have found. So based on this, right, it seems that this malware is attempting to retrieve the credentials from of the user from the device, and giving it a unique identification number to identify it within the list of within the within a list of machines that the attackers get a hold of. So this is most likely the a possible way that the malware actually uses to ensure that they do not reinfect the same device by being able to read the data and check if this folder has been created. And that is all for the analysis for the advanced dynamic analysis.